Okay, let's talk about writing equations from a point and a parallel or a perpendicular slope. To start off with, what do we know about the slopes of parallel lines? Don't forget that a slope is a direction. It literally tells us which direction our line is headed as we move from left to right. So what about these two lines? These two lines are parallel. What do you know about the direction of these lines? Aren't they headed in exactly the same direction? Well, the slope of any set of parallel lines are going to be equal since they are headed in exactly the same direction. So if I have an equation, y equals 1/2 x minus 4, and I know that I can find its slope, right, y equals mx plus b, our slope is 1/2 in this equation. So if I asked you, what would the slope be then of any line parallel to this one? Well, its slope would also have to be 1/2. How about perpendicular lines? Here I have a set of lines that are perpendicular. Let's take a look at their slopes. The first line, our blue line, has a slope of 1/2. It goes up 1, right 2 when I go from point to point on the grid. Taking a look at the second line, if you find a couple of points that are on the grid here, you'll see that this line goes down 2, right 1, which gives us a slope of -2. And I can write that as a fraction to help us kind of relate those perpendicular slopes a little more effectively. If I take a look at the slope 1/2 and the slope -2 over 1, how are those two values or numbers related? They are definitely related. We actually call those opposite reciprocals. First of all, opposite because they have opposite signs. One is definitely positive and one is negative. And they're reciprocals because they're the same fraction, just flipped. So opposite reciprocals will always be the slopes of perpendicular lines. If you have one that's 2/3, the other one's going to be -3/2. If you have one that's 5/7, the other one's going to be -7/5. They will always have opposite signs and the fractions will be flipped. So now let's look at an equation, y equals -2/3 x plus 5. First off, what is its slope? The slope of this line is 2/3. I know because of the coefficient in front of the x. And if I asked you what the slope would be of any line perpendicular to this one, that would be +3/2. Change the sign, flip the fraction, right? Opposite reciprocals. So now let's look at some examples when I'm asked to write the equation of a line given a point that the line actually goes through and an equation where we have to be parallel or perpendicular to the given line. So let me clarify. Let's say that we were asked to write the equation of a line that goes through the point 4, -2 and also is perpendicular to the line y equals 4x plus 5. You can't really come up with this in your head right off the bat, so let's take a look at some information that will help. First of all, what slope do we need to be perpendicular to? In other words, what's the slope of our original equation? That would be 4, right? Well, if my slope needs to be perpendicular to 4, what's my new perpendicular slope? Remember, this is the same as 4 over 1. A slope that's going to be perpendicular then would be its opposite reciprocal, or -1/4. So I'm going to take that new slope of -1/4, and that's going to help me out. We have our new slope and the point that that new line is supposed to go through. And since I do have a slope and a point, didn't we just talk about point-slope form? Well, that would make sense since you have a slope and a point, right? Point-slope form. So I need to label the values that I have. I have slope, which is m, and a point, which if we're using point slope form is x1 and y1. Then I simply substitute those values into my formula. -2 is y1, -1/4 is m, and 4 is x1. Then I can simplify. My double negative becomes a positive, and I can distribute the -1/4 through my second set of parentheses. -1/4 x, and a negative times a negative gives me a positive, and 1/4 of 4 is 1. Then to put this in slope-intercept form, I'm going to subtract 2 from both sides, and I get y equals -1/4 x minus 1. And that is the equation of our new line. That line will have two properties. It goes through this point and has our new perpendicular slope. You can graph that on a coordinate grid if it will help you visualize. Let's try another. Let's say this time that we want to write the equation of the line that goes through the point -112 and is parallel to the line y equals -3x minus 8. So first of all, we need to know the slope of our original line. And in this case, it's -3. So we have a slope of -3, but now we need a line that's parallel to that original line. So if my original slope is -3, what's the slope of the line parallel to it going to be? Well, parallel slopes are exactly the same, so I'm still going to use a slope of -3. Be really careful to take note of whether it's asking for a line parallel or a line perpendicular. So now I'm going to take my new slope, which is the same slope, right? And the point that it's supposed to go through, -112, and I'm going to plug that into my equation. Only this time, I'm going to show you a different way. Point slope form is absolutely wonderful, but it's not the only way to find the equation of our new line. I can actually call my new slope m and my point that it's supposed to go through x and y, and I can simply use slope-intercept form. Again, point slope is a great way to solve this. I could absolutely use that, but this is yet another way. I have 3 values, m, x, and y, that I can replace or substitute into my slope-intercept form. Y is 12, m is -3, and x is -1. The only value I'm missing is my y-intercept, or b. Well, simplifying this, I can multiply the -3 times the -1. That gives me a +3. And when I subtract 3 from both sides, I get b equals 9. That's my new y-intercept. Well, remember, to write the equation of a line in slope-intercept form, all I need is a slope and an intercept. So I can replace those or plug them into slope-intercept form, and I get y equals -3x plus 9. Let's look at that with slope-intercept form one more time. This time we're asked to write the equation of a line that goes through the point -3, 5 and is perpendicular to the line y equals -3/4 x plus 2. So my original slope is -3/4. It's asking me for a line that's perpendicular. That means our new slope needs to be its opposite reciprocal, or +4/3. That's the slope I'm going to use in my new line. So I need the equation of a line that has a new slope of 4/3 and goes through the point -3, 5. I can use point slope or slope intercept, whichever one you prefer. Both will give you the same result. I want to show you one more time with slope intercept form. So that's what we're going to do. We're going to call this m, x, and y, hopefully for obvious reasons. And I'm going to substitute those into my slope intercept form. y is 5, m is 4/3, and x is -3. To simplify, I need to multiply the 4/3 times the 3, so I can multiply those two fractions together, and I get a result of -4. Remember, 4 over 3 times -3 over 1, you can only multiply fractions by other fractions, and simplifying the result, I get -4. So I have 5 equals -4 plus b. Adding 4 to both sides to isolate b, 5 plus 4 gives me b is equal to 9. And again, to write the equation of a line in slope-intercept form, all I need is that slope and intercept. Substituting those in for m and b, I get an equation of y equals 4/3 x plus 9. I now have the equation that's perpendicular to the line I was given, and we'll go through the point -3, 5, and I do encourage you to graph both lines so that you can visualize what's happening. Alright, I think I've taken up enough time for you today. I hope that the rest of your day is fantastic, and I will see you next time.